So we're going to continue today with our unit on solving systems. And the first thing that I want to establish is that we are going to be doing the exact same thing today that we did yesterday. We're going to be doing it a different way, but we're going to be doing the exact same thing. So what was it that we were doing yesterday? I know. And I'll even help you out there. I even tell you, yeah, we were solving by graphing. But when we solved by graphing, what were we doing? Oh, great. Look at that. But I like these other. Or you can just try to answer questions, and then that way you can get your own. Today we're doing the exact same thing. We are still looking for the intersection. We're just not going to draw anything. Okay, we're going to be given two equations with two variables each, and we're still looking for where they cross. You just don't actually have to draw anything. The nice thing about graphing is that it's visual. So yesterday you got to see the intersection. But what's the bad thing about graphing? Why don't we normally like to graph as a consistent means?
Because you have to get it exactly on the point.
Say it better.
So
What's
it's hard
the,
to see.
how did I word it? Yara? Say it again? Okay, good enough. I like the word. It lacks precision. It isn't as precise as a method. Whereas today we're going to learn two algebraic methods. Both of these are exact. They are precise. We're going to know exactly where the lines cross, even if that point happens to include decimals and or fractions. Okay. Another thing to try to establish right at the beginning, that even though there's two algebraic methods, and the methods might appear to be different, they're not as different as you might think. I'm going to try to show you that by comparing and contrasting. And understand, they're going to give you the same thing. If I get one system, it's not like, oh, if I graph, I get one solution. And then if I solve by substitution, I get another solution. And if I solve by elimination, I get, it's all the same thing. We're looking for an intersection. The example I give, the very drastic example I give is, back where I used to teach, probably about 10 years ago or so. I was teaching a class. It wasn't Algebra 1, but it was a remedial class that included Algebra 1. I had a student, okay, fine, she was pretty intelligent, but she also was absent all the time, hardly ever here. So today, the two algebraic methods are known as elimination and substitution. So this student happened to be here when I taught substitution, but was not here when I taught elimination. Now, on this quiz that I gave the students the option. You're going to have a test next week, or on the majority of them, you're going to have an option. I'd say on most of them, you'll have an option, but on some of them, you will have to use a certain method. It'll be dictated what method you have to use. But just for the sake of the story, I gave the students which option they wanted to use. Any system can be solved by substitution. Any system can be solved by elimination. But if you do not possess the ability to use both of them, what happens is you're hindering yourself because you're going to have a lot more work to do. There's definitely some systems that it's much more efficient, it's quicker to solve by substitution, and there's some where it's quicker to solve by elimination. So back to the story, right? The student was only here for substitution, took this quiz only knowing substitution. What do you think the student got on the quiz? A bad grade? How good? Got 100%. Now, she did not do herself any favors. And the thing with substitution is that if the numbers aren't, if the numbers don't work well together, you're going to encounter some really nasty fractions. But hey, the person was able to do it and they still got 100. Because I need to establish right off the bat. Some people think that, like, oh yeah, this system I can only do it with substitution, or this system I can only solve it with elimination. No. As far as choosing a method, there is no wrong way to go. There's a better way to go sometimes, or there's a quicker way or easier way, whatever you want to call it, but there is no wrong choice. If You give me any system that you got a pretty thick packet of notes. I can solve every single one of those by substitution. I can solve every single one of those by elimination if I wanted to. And I will get the same answer both times. But yeah, we will try to talk about maybe what's the smarter way to go, what's the quicker way to go by comparing and contrasting the steps. So let's take a look at that. Instead of just reading these to you and boring you even more than you may already be, let's compare and contrast the steps for the two. And I'll actually start you at the end. What are the last three steps of substitution say to do? Solve, substitute, solve. I have underlined and capitalized the verb for you. What are the last three steps of elimination? Ask for you to do the exact same things. You're right. They're exactly the same. Now, these steps were things that I created, and I tried to arrange them in a way so that we can compare accurately, so that there's uniformity, and we can accurately compare and contrast. So if I've made both of these into a 5-step process, and we can all agree that the last 3 steps of each are the same, well then, geez, how are they different? The first 2 steps. Now, the first 2 steps actually have a common goal, and we'll get to that. We're actually trying to accomplish the same thing in the first 2 steps. We're just doing it a different way. Okay? Specifically, if you look at the second step is where each process gets its name. What is the second step of substitution? To substitute. What is the second step of elimination? Substitute. It helps to listen, Jay. Like it helps to if the second step is where it gets its name, the second step for elimination is to eliminate. Now there's no eliminate button on a calculator, so to be more specific, when you are eliminating or actually adding. Second step, number 2. Okay, so now even though we're going 2 different ways, and I know that you might know this stuff, but just please don't be time for that. You have plenty of time. You might hear something that you haven't heard before. Even though this is 2 different ways to go about it, the first 2 steps actually accomplish the same thing. And I'll try to stress that to you through the examples. Okay. Now, the significance, so we've talked about a fact about the last 3 steps. I've just given you a fact about the second step. What I haven't talked about is the first step. How is the first step significant? I think the first step is significant as far as choosing a method. Here, Jair, you can, if you are ever given a choice, if ever, whatever, it doesn't have to be in math, it could be in anything in life. Here, Jair, you can do this or you can do that. What are you likely to choose? You and probably the rest of the modern world. What are we most likely to choose? The first one is so that if I say, hey, Jair, you can go and either jump off a bridge or eat candy. You're going to jump off a bridge because that was the first option? Say that again? Yeah, whatever's easier, right? And when are things the easiest? What's the easiest thing for anybody to ever do? Okay. Okay, Colin. Mom says that when you go home, you have to clean your room. What would be the easiest way to have your room clean? Just hang all the stuff? Yeah. I can think of an easier way than that. Save it? Maybe, yeah, maybe, but no, it's even easier than that. You guys aren't being honest with yourself. What's the easiest way to get something accomplished? Just say it again? You know what? I even word that. Thank you. Somebody's being honest. What's the easiest way to get something done? Have it done for you. You got a little brother, hey, 4 cents to clean your room for you. Hey, you gotta mow the yard, hey, pay somebody to do it, right? That's the easiest thing. Have it done for you. Nowadays with technology, we can have so many things done for us. So how does that apply here? Well, if we look at the first step, I would go a certain path if the first step is already done for me. So like, what's the first step for substitution? Solve for one variable. You should have already learned this year. What does solve mean? Isolate. So if I already see that a variable has been isolated, it doesn't have to be y. You guys are used to always y has to be by itself. It doesn't have to be y. But if you see a variable that's already by itself, cool. I'll do substitution. Elimination. First step says both equations in standard form. We know what standard form is before. If you see both equations in standard form, I'm going to tend to do elimination. But again, there is no wrong choice. If I get both equations in standard form and I say, hey, Mr. Romero, well, I'll show you, I'm going to do substitution. Fine. If you do it right, you'll get the right answer. The only thing is that you have to solve for that first variable yourself instead of having it done for you. If you have a variable that's already solved for, and you say, hey, watch, I'll show you, I'm going to write both equations in standard form, okay, go for it. You'll still get the right answer. We're not talking about what's right and what's wrong. We're talking about what's the quickest, what's the most efficient. So watch here, let's get to the good part, the one you've been all waiting for. Here's your first system. We'll do the first 4 together, and then anytime we have after that, I'll start randomly picking them so that people don't get too ahead of themselves. And we'll see if you can do them on your own end. I have two variable equations, what we call the system. Yesterday we would have got each of these, we would have graphed them, and we would have seen where they crossed. Today we want to solve this algebraically. The second equation I can see is in standard form, but the first one isn't. But besides that, do I have any variable that's isolated? Do I have any variable that I already know the value of? Which y? The top y. So here's the logic behind it. Here's how this works, right? If I were to have 2 lines, and if they were to cross, we don't know for sure yet that these are going to cross. Who knows? They might be parallel, they might be on top of each other. But if they were to cross, at that point of intersection, they would share the same x and the same y. So like this statement of equality on top says that the top y is the same as 3x. But I'm only interested in where the top y is also the same as the bottom y. So I could use that to my advantage and say, okay, now go read the steps so that we can, if I don't write it, you don't write it. So just so that we all know, I'm going to go ahead and do substitution. And if I were to label, I won't do these always, but the first few I will do these. Jay, you're going to hurt somebody, man. Maybe even yourself. I'm going to stamp this. It's my stamp of approval. Step 1 for substitution is done already for me because one variable is already by itself. What does step 2 say to do? Yes, Jair. There you go. The third time it says the same word today. Good. Substitute. So, and not only substitute, but substitute into the other equation. So I'm going to get that value of the top y, the 3x, and I'm going to write the other equation, the second one, but instead of a y, I'm going to write a 3x. So here comes your candy question. I told you that even though the first 2 steps are different, they both accomplish the same thing. So even though you haven't seen elimination yet, what have I accomplished? What's different below that black line as opposed to above? What's different about what you see below the black line as opposed to above? Yes. Ollie, you want to try again? Do you have your hand up again? Yeah. Obviously, we already agreed on that one. How has substitution changed? What I'm looking at. Martha, you had a no? Lily? There's no more y. Now, not because we don't like y's, the y's have to go. No, it's just we're trying to get from 2 variables to 1. When we get to elimination, what are we going to eliminate? We're going to eliminate 1 variable. When we do substitution, why do we substitute? Because we want to get rid of a variable. Because now when you go from 2 variables to 1, that allows you to continue, and we can start our process of solving, which is what we came to do in the first place. Okay, I'll put my stamp of approval. Step 2 is done. Now let's solve like a full kids do. 2x times 3x is 6x. 7x is equal to negative 21. Divide by 7. Hey, what happened to my marker? X equals negative. Yeah, I'm done. No, I'm not. But something has been revealed to me. If you are able to complete step 3, that tells you the type of solution. Step 3, which is what I'm working on now, I just finished it. Step 3 will tell you the type of solution. Yesterday, we used other indicators to try to reveal the type of solution. Go ahead, Ann. Y-intercept, Ann, and slope. And by the way, and I'll have to remind you also, because we were talking about the test today in the Algebra I meeting, there's going to be a question at least that revolves around that, where now they just want to know, hey, the type of solution, and it's going to ask you to justify. So we're going to have to look at those factors again, the slope and the y-intercept. What causes two lines to intersect once?
Oh, different slopes.
Different slopes. They have different slopes you cross once. What causes parallel lines? Same slope, different y-intercept. What causes two lines to pop up together? Same slope, same y-intercept. There's going to be a question like that where you're going to have to write it and justify it. Say why. Give the reason why. Now here, algebraically, if I'm able to finish this, since I'm not looking at slope, I'm not looking at y-intercept. If I'm able to finish this step, I know there's going to be one solution. If I am not able to solve for a variable, that means either no solution or infinite solutions, and I'll show you the difference. But if I'm able to finish this step, I know there has to be one intersection and thus one solution, but I'm just missing the y. Question, Kiara? Yeah, that's what I did. What I did is I got this 3x and I put it in for y. X plus, sorry, I went too far with the line, I'm sorry. X plus 2. Instead of y, what did I put instead? 3x equals minus 21. Everything is exactly the same except for instead of a y, I took it out and put a 3x. Okay, now, see, part of the reason why kids don't like substitution overall is, like, I'm going to take it away from you. No, there's other things to be doing. That's not one of them. Thank you. When this first step is not done for you, the kids don't like this isolating up here because it could cause fractions, it could require a lot of steps. But the nice thing about substitution is that the end is a lot quicker. Because if I have x, what am I looking for? You're looking for y. With substitution, at the end, you're always going to have that last variable you're looking for by itself somewhere. So yeah, technically you could pick whatever equation you want now. But if I'm looking for y, I'm going to pick the one that has the y already by itself. And that'll be step 4. You substitute again. I'll say y equals. Up there it said 3x. But now I know that x is negative 3. So y equals negative 9. Step 4 was when I substituted over here. Step 5 is when I solved. And now I'm done. On the test that you take next week, part of what you're going to be judged on is your ability to write an ordered pair. Okay? X comma y. Not the order you solved it. There's going to be some of these where you end up solving for y first and then x. If I would have solved for y first and then x, I'm not going to write negative 9, negative 3. I'm still going to write it as an ordered pair. The order being alphabetical order. Negative 3, negative 9. Because we're not graphing anymore, every variable is not going to be x and y. You might have a's and b's, in which case you write a comma b. You might have c's and d's, so write c comma d. The order in ordered pair is alphabetical order. Emiliano, any questions? All right, let's do another one. We'll do the first 4 together. And then after that, I'll start randomly picking them. We're not going to do all of these today. But when we don't finish today, I'll give you the option of doing tomorrow. Tomorrow, we're going to take a nested approach. You guys will choose what you do. Yeah. Twirling a necklace around is not going to be one of the choices, though. Okay, what do we see here at the beginning? Yeah, we have 2 equations in standard form. Does that mean that you can't use substitution? No, look. But I fell in love with substitution. It was love at first sight. Okay, well, look, if you wanted to be smart about it, I'd probably use the top equation. And even though no variable is by itself, I could just do minus 5y minus 5y. And bam, I have a variable by itself. I would get this and plug it in for the other x, and I'm all set. And I could do substitution. But I want to give you some variety. And I told you that the more efficient way of solving when you have 2 equations in standard form is to use elimination. So let's go with elimination. Now, in order to use elimination, it's more than just standard form. We also need matching coefficients and different signs. What's a coefficient? Yeah, good. Yeah, it's a number that is right in front of a variable, right? So if we look at the x's, the coefficients are the same. The top x has a 1 in front, the bottom x has a 3 in front. If we look at the y's, a 5 and a 2. I'm not worried about the signs yet, though. The signs will come after. We're going to do the signs afterwards. But here, I don't even have matching coefficients, so I have to make them match. This is what you were asking about, Marquise, elimination. Okay. So the way that we make them match is by doing what's called least common multiple. It's the same skill you use when you try to make fractions the same. So like here, the x's have a 1 and a 3. Imagine I had a fraction with a 1 on the bottom and a 3 on the bottom. If I wanted to make them the same, what would the LCD be of 1 and 3? It'd be 3. If you're not sure, count by that number. Count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then count by threes. 3, 6, 9, 12. What's the first number they have in common? 3. So if the x's are going to match, they need to match at 3. The bottom x is already a 3, so I don't have to touch it. But I have to change the top x to make it into a 3. You don't have to choose the x's. You can also choose the y's. If I want to make the y's match, what is the least common multiple of 5 and 2? It would be 10. So I'd have to turn them. Now, none of those are currently a 10, so I'd have to change both of them. The way you change them is by multiplying. Marquise, I'll let you pick. Do you want to make the x's match or make the y's match? You want to make the x's match. Okay, so we said the x's would match at 3. So I can leave the bottom x alone. The top I have to multiply by 3. Now that'll make the coefficients the same. They'll both be a 3, but I need them to also have different signs. Okay? Correct. So what I need to do then is multiply one of the 2 equations in addition to that by a negative 1. Normally I like to do it on the bottom, but since I'm already multiplying on the top, I'll just make, instead of making this 3 positive, make it negative. It's up to you. It's just a matter of choice. So in that way, what that allows me to do is leave my second equation completely untouched. I can just still write 3x minus 2y equals 8. And really, honestly, if you wanted to, you could even write that on top and then write the other one on the bottom. It doesn't make a difference. The top equation must stay on top. It doesn't matter. But I don't want to confuse you, so I'll leave that on the bottom. Then up here, we would have negative 3x minus 15y equals positive 9. Do I have matching coefficients? Yes. Do I have different signs? Yes. So step 1 is done. Now that step 1 has been cleared, it clears the way for step 2, which Jair is 2. Say it better. Use the correct part of speech. Okay, and now it is eliminate, but the candy, how do we eliminate? Eliminate how? Elimination by addition. So watch. Ha! the elimination part, but you have to understand how we did it. How do we do it? By adding. So you got to add everywhere. Negative 15 plus negative 2 is negative 17y. 9 and 8 is positive 17. Divide by negative 17, divide by negative 17. By the way, something I want you to notice, if you look underneath the black line, once I did my PAL, how many variables do you see? Just one. So elimination accomplished the same thing that substitution did, which is I went down to one variable. And now that I finished solving, because solving is step 3, I now know that my system is going to have how many solutions? One solution, because I was able to solve. I got the y of the intersection. I'm just missing the x. How would I find the x? Substitute. You can pick any equation you want with elimination. A lot of times you're not going to find one that's preferred. Just pick any one. It doesn't matter. Pick whichever one you want. I'll use the top one. So I'm looking for x. So I will write x plus 5y, which y was negative 1. So equals negative 3. Every time you substitute, what happens? Well, you should have, like, this is a way to check yourself. Every time you plug something in, you should only see one variable. How many variables do we see here? Also one. If you see an x and a y, you did something wrong. You didn't substitute correctly. So that was what I call step 4. Finally, step 5 is when you solve for, you get x minus 5 equals negative 3 plus 5, and x equals 2. How would I write this as an ordered pair? 2, negative 1. Even though the x came second, alphabetically it comes before x and then y. Yeah, that's you gotta be careful with. And that's gonna be an entire quarter of every question is gonna be based on, do you know how to write it correctly? Georgiana, you scared? Okay, 2 more and then I'll give you guys a choice. If you've been listening to what I've been saying, what would be the smarter approach for this one? I would also say substitution. Why? Because the first step's already done for me. Be likely when things are done for me. Because a variable's already by itself. Which variable's by itself? Which y? The bottom y. So if the bottom y is the same thing as 3x plus 2, which is what the equal sign is telling you, then I could say that 3x plus 2 is also the same as the top y. So I could now rewrite the top equation, Kiara. 6x minus 2, but instead of y, what am I going to write, Kiara? Fantastic. Equals negative 4. And when you look at that, how many variables do you see? Okay, I know I see 2 of them, but how many different variables are there? Just one. Which, what does that allow me to do? By the way, step 2 is done, substitution is done, and that now allows me to solve. Uh-oh! Problemo. I'm trying to solve for x, but what just happened? Yeah. Spaghetti goes. I'm trying to solve for x, but all the x is canceled. You should have seen something similar to this when you did one variable equations before I got here. What did your teacher to do if you're trying to solve an equation and all the variables cancel? What am I hoping they taught you to do? Drop the leftovers down as if they were hot. What are the leftovers? Leftovers say that negative 4 is equal to negative 4, and then ask yourself, is this a true statement? Yes, if I am not able to complete step 3, the only thing I know so far, I can't have one solution. If I wasn't able to solve for x or y, I know that this will not cross once. But what I'm trying to differentiate is it because they're on top of each other or because they're parallel? If what you have left is a true statement, this is known as an identity, which we have infinite solutions. If I were to graph both of those lines, how would they look? They'd be on top of each other, yep. Any questions there? Okay, this is the last one we'll do as a group. What would you suggest we should do first here? Or sorry, what method do you suggest we should use? Somebody not named Colin. Shiobi, what method would you say? Okay. Now, if she chose substitution, would she be wrong? She wouldn't be wrong, but she'd have to do more work because there is not a variable anywhere here that is by itself. So I'm not saying that you're wrong, but I wouldn't choose that. I would choose elimination. Why would I choose elimination? They're both the same. So I'm going to choose that, Colin, since you've been so great today. Elimination requires that one of the variables has to have the same number in front. Currently, the x's don't because I have a 2 and a 1, and the y's don't. So I have to make one of them match. I'll let you pick. Do you want to make the x's match or the y's match? All right, so let's make the x's match. The top x has a 2 in front, the bottom x is a 1 in front. What's the least common multiple of 2 and 1? It is 2. Since the top already has a 2, I don't have to touch it. But then I have to multiply the bottom by 2. In addition to that, the signs are not different. Okay, in order to be able to eliminate by addition, look, I used to teach it 2 ways. There is also elimination by subtraction, but I just got so tired of kids making mistakes with signs that now I only teach it with addition. But in order for addition to work, yeah, the signs got to be different. So yes, I'm going to multiply by -2 because that will ensure that 1, 2 is positive and 1, 2 is negative. Step 1 is will be done afterwards. 2x plus 2y equals 8. Negative 2x minus 2y is equal to 4. Colin has a thing against x's, so bang! What? Will you look at that? I meant to cancel out the x's. That's what my step 1 was intended to do. But by coincidence, the y's canceled also. So Lily, what am I left with on the left side? Good. There's a number for that. The number is 0. What am I left with on the right side, Lily? Come on, Lily, we don't want to be grounded anymore. Jada? On the right side, no? Yeah, the left side is nothing. Everything canceled. The right side would be, it is 12. So the question is 0 the same as 12? And because I do not have a true statement, that means the system has no solution. If somebody were to ask you, hey, you know what? I feel like graphing this. Can you predict what the graph would look like if I were to graph those two? They'd be parallel lines, yeah. Okay, so what I'm getting used to is certain sneaky people like Ann over there like to get ahead. So I'm gonna randomly pick some from the examples to come. You find it, you solve it, you get rewarded. So let me find which ones I wanna see. Okay, I like that one. Find that one, do that one. Did you get more keys? Yeah. We got the hang of elimination. Now, more keys. This one probably should have taken as little time as it did, because a lot of it was already done for you. And I'm hoping he realized both equations were in standard form. But besides that, what else did we already have? Yeah, we have matching coefficients already. There's no rule that says you have to eliminate the x's first, but why wouldn't you want to? It's perfect. It's set up for it. I have different signs in front. They both have a 1 in front. Bam, they're gone. One has a positive 1 in front, one has a negative in front. But when we eliminate, what are we really doing? Subtracting. We're adding 5 plus negative 1 is the same as 5 minus 1. We got negative 4y. Add here, we get 28. I'm not going to label the steps anymore, but we've eliminated. How many variables do we see? How many variables do we see? That's 1. Now we divide. And since I was able to solve for one of the variables, I now know that I'm going to have one solution. I just don't know the x. I can pick any equation I want to solve for x. I'd probably use the bottom one if I was you, just because I'm scared that you guys would make a mistake with this negative in front, but either one will work. But I'd probably go with the bottom one, more right than x minus, not 7, sorry, not y, but x minus 7 is equal to 15. So plus 7 cancels. X is equal to 22. Somebody not named Colin, tell me, or Marquise, tell me what's the solution here? Yeah, Kiara? Yeah, make sure you write the 22 first. 22 plus 7. Emiliano, you got the same thing? No. Okay. Okay, that one there. Right now, you downloaded it before our homework. Solve. Colin? Nope. Go ahead, Marquise. Unless we're doing it wrong, that's not what I'm getting. It was. What you said right there, you said what negative 1? Sorry about that. Yeah, yeah, right. Sorry about that. Okay, so since the bottom x is solved for, we would plug that into the top x. So 2 times negative 4y plus 8. By the way, we're going substitution. Anybody disagree with that? We have a variable solved for. Then continue to write it, minus 5y is equal to 29. Okay. How many variables do you see? Yeah, just one, so let's solve for it. Negative 8y plus 16 minus 5y is equal to 29. Negative 13y plus 16 is equal to 29. Minus 16 minus 16. Negative 13. Y is equal to 13. So divided by negative 13. Now, since I was able to solve for one variable, I know I should be able to solve for the other one. The nice thing about substitution, you're always going to have one equation that has the variable that you're looking for already by itself. Not that I can't use the 2x minus 5y, but I'll just use the bottom because that is already by itself. So x is equal to negative 4y, but y is negative 1, so negative 4 times negative 1 plus 8. So x is equal to 4 plus 8. X is equal to 12. So we got one solution. The x goes first. That's 12. So maybe get 2 more done before the bell. This one here, do this one. Okay, Marquise. Yeah, wow, you're on fire, man. See how you got infinite solutions. What did you choose to use, Marquise? What did you choose to use? Okay, so he chose elimination. But look, watch. This is a perfect example. So he chose elimination. He got infinite solutions. Let me then do substitution just to show you that it would also work. Now, if I use substitution, nothing's solved for me, but I do have this y that has a 1 in front. So I'm going to choose to go minus 2x and minus 2x. So then say that the top y is equal to negative 2x plus 4. I just want to show you that picking a certain method does not affect your solution. You got infinite solutions, right? Let's see what I'm going to get. So then I go to the bottom and say 6x plus 3, but not times y, times negative 2x plus 4 is equal to 12. So 6x minus 6x minus 12 is equal to, plus 12, thank you. That should be plus 12. So once all the variables canceled, he knew that there was not going to be one solution. I'm ending up with 2 equal numbers, so this system has infinite solutions. If I were to graph them, what would they look like? It would be? Yeah, it'd be the same line. Let's see if we can do one more. Yeah, do that one. Oh, way at the end. You send me those pictures, please. Martha, you finished? Brandon, I haven't heard from you today, man. Sitting this one out. Come on, Nakai, you can do it, man. Sam, you got it? What'd you get? Good. So let's see how she got that. What method did you choose to use, Sam? Yeah, I would do elimination because here these are both in standard form. But no, okay, let's do a hypothetical. If she were to use substitution, what variable would it be in her best interest to solve for? Since none of them are currently solved, which variable should she isolate? If she wanted to use substitution. Which x? The bottom x, yeah, I do that too. But okay, so she chose, so elimination, which variable did you choose to eliminate? What, that would be the x's, and you chose to get rid of the x's, so I multiply the bottom by -2 because I need the signs to be different. So the top equation stays the same. The bottom equation would be 14. So her intention was to get rid of the x's, but coincidentally, the y's cancel out too. So really, what are we left with on the left side? 0. What are we left with on the right side? Good. Is that a true statement? Is the number 0 the same as -10? No, it is not. So Sam is enjoying her Twizzlers now because make sure the wrappers don't end up on the floor. Any questions for me? All right, so like I said, tomorrow I'll have kind of like a self-paced type of lesson where you guys decide what, I'll give you options and you pick what you want to do. Sleeping is not an option.